Hi all. So want to talk about so we've talked about limiting reactants, we've talked about how to figure out what the limiting reactant is, but how do you figure out how much of the excess stuff is left? And so the way to do this is to first figure out the limiting reactant because you need to figure out what the excess reagent is. And so you have 14 grams of um, carbon disulfide and 4.5 grams of chlorine gas. Okay, those are both reactants. Set them up like stoichiometry wise and figure out how much product you would get using each. Now, because I'm not asking you for how much product you would get or how much of a specific product you would get, it doesn't matter what product you use. Just pick one, make sure it's the same, and figure out how much product you could get. Okay, so let's figure out the limiting reactant. 14 grams of CS2, grams of CS2 go on the bottom. For every 1 mole, so I give you the molar mass, I have 76.14 grams of CS2. And for the purpose of whatever, I'm going to pick this as the product we're going to go to. And so for every 1 mole of CS2, I have 1 mole of carbon tetrachloride. I picked this one. You could totally pick this one. Doesn't matter. What you're trying to do here is figure out what the limiting reactant is. Okay, so doesn't matter which one you pick. Just pick one. So I'm going to do that. That's going to give me an answer. And then I'm going to do the same thing with the same product for chlorine gas. And so I have 40.5 grams of Cl2, molar mass of Cl2, 70.9 grams of Cl2 for every 1 mole of Cl2. And the mole ratio here is actually 3:1. So for every 3 moles of chlorine gas, I have 1 mole of CCl4. And so when I plug this in my calculator, I get 0.1839 moles of CCl4 here, and 40.5, 9 times 3, 0.19040 moles of CCl4. And so next question you want to ask yourself is, all right, which is giving me the lesser one, which is my limiting reactants? In this case, they're pretty close. But here's your limiting reactant, and here's how much product you would actually make. Okay, so I'm actually going to make that much of CCl4, but this is what I could make if I used the other one. And so in order to figure out how much stuff I'm going to have left, so there are a few ways you can think about this. I'm going to work through it this way. You can pick a way that works for you and go with that. That's totally fine. And I didn't go to grams. You can go to grams if you would like, but moles works as well. It's actually maybe a little bit easier. And so I'm going to now subtract the excess stuff from what I'm actually going to make. And so 0.19040. You'll see that I'm leaving a little more significant figures just to make sure I have a little bit better accuracy. Minus 0.1839, which gives me 0.00651 moles of CCl4. So this is how much CCl4 would actually be left over if, like, for my excess reagents. And so now I'm going to work backwards because the question is asking me for how many grams of excess reagent are going to be left. If I know moles of the product that are going to be left, now I'm going to go from moles of the product to moles of my excess reactants. In this case, I figured out that my excess reactant is Cl2. And so to figure that out, I'm going to take my moles of CCl4, 0.00651 moles of CCl4, convert back to moles of chlorine, using my mole ratio, for every 1 mole of CCl4, I have 3 moles of Cl2. And because question is asking me for grams, I need to go back to grams. For every 1 mole of chlorine gas, I have 17.9 grams of chlorine gas. And so I have times 3 times 70.9, 1.38. Well, two significant figures because this is 2 sig fig. So 1.38 grams of Cl2 or 1.4 grams of Cl2 would be left over after I'm done. Okay? And that's it.